This recording is for Chapter 3, Section 4, Zeros of Polynomial Functions. In today's lesson, we're only going to cover the first half of Section 4. It just takes a lot. There are quite a number of topics that are in it, not necessarily hard, but long. So I decided to split it into two. So we'll cover the first half today, and the next half is tomorrow's lesson. So let's get going on this first half. We've been working with zeros of polynomial functions quite a bit lately. Each nth degree polynomial will have n zeros in it. If a polynomial has n zeros, it must therefore have n factors that led to those zeros. Okay, so these are things that should be pretty familiar to us. The fundamental theorem of algebra states that if f of x is a polynomial of degree n, where n is greater than 0, then f has at least one zero in the complex number system. Let's take a look at this one. It's checkpoint number 1 from page 275 in your textbook. It says determine the number of zeros of the polynomial function x to the fourth minus 1. Now, because it's a fourth degree polynomial, I can deduct from that I'm going to have 4 zeros, but let's go ahead and find them and prove that fact. So x to the fourth minus 1 is a difference of two perfect squares. So first step I'm going to take is to factor it into an x squared minus 1 and an x squared plus 1. Now, taking a look at those two, hopefully you notice that first factor, x squared minus 1, is again a difference of perfect squares. So I can break it more into an x minus 1 and an x plus 1. X squared plus 1 is not a difference of squares, so it can't be broken with that simple factoring, but I can go ahead and set that factor equal to 0 to find my zeros this way. We'll just do it algebraically. Now to unsquare my x squared, I'm going to take the roots of both sides. So x will equal plus or minus the square root of negative 1, which is plus or minus I. So my zeros end up being 1, negative 1, I, and negative I. And sure enough, you can see the 4 zeros for this function. There's also something in this chapter called the rational zeros test. When we're trying to come up with the zeros, we're not always going to be able to factor like we could in the last one. Okay, so we do a lot of trial and error to try to figure out the zeros. Well, you don't want to have to figure out every single number and fraction that could possibly be a zero to your polynomial. So this rational zeros test gives us a way to kind of narrow it down a little bit. What you're going to do is you're going to focus on the constant term of your function and also the lead coefficient of your function. The ratio of the factors of the constant term over the factors of the lead coefficient are the only possible numbers that you need to test. So for example, on this one, this is checkpoint number 2 on page 276. If I wanted to find the rational zeros of this function, I focus on the 8, which is my constant term, and a 1, which is my lead coefficient. So all of the factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And the only factors of my lead coefficient are plus or minus 1. So these combinations of numerator-denominator are the only possible numbers that we have to check. All right, so you would never worry about does 3 end up being a 0, does 5 end up being a 0, and so on. They're not in this ratio. So they aren't going to be. You don't have to test them. It'll save us some time. So let's start finding our zeros now that we have a limited amount of things to check. Just to let you guys know, I did work a positive 1 through synthetic division first, and it did not turn out even. I moved on to negative 1 then. So just to show you that it does work, I'm going to run that one through it this time. So working our synthetic process, you see that I do in fact come out with a 0. Now, I know that x minus 1 is a 0, or negative 1 is a 0. So x plus 1 would have been one factor. Now, if I take that out, I'm left with another polynomial, a smaller polynomial, because it's going to be a factor smaller than the original. This synthetic division results in this polynomial. Now, there are more zeros to find, But I don't need to go back to the original function to come up with them. I can just look at the leftovers. All right, so that first 0 is out of there. I don't need to consider that the full thing, just the leftover. Now you could go on to check more numbers. Maybe you wanted to check a 2 or a -2. But frankly, once you get to this trinomial, you're very likely just going to be able to factor it the fast way. So a -4 and a -2 would give us our +8 as well as our -6x. So my next 0 is going to come from this factor, and my next 0 from this factor. So I found the first one with my trial and error. I got -1 out of there. And then I was able to do the rest relatively quickly by factoring that remaining polynomial with my -1 out. To find the rational zeros when the lead coefficient is 1 then, figure out all possible zeros like we did with that ratio thing. Once you find one, get it out, and then just use what's left over to continue checking. You might be able to factor at that point, or at least it's going to be a smaller synthetic division to continue with. So let's take a look at this one. This one's checkpoint number 3 on page 277. Find the rational zeros. Okay. My constant is -125. So the possible factors of -125, plus or minus 1, plus or minus 5, plus or minus 25, and plus or minus 125. And my lead coefficient is 1 again, so that's nice. I have very few options for the bottom of this ratio. And you just begin checking again. In my own work, when I was working on doing this example for you guys, I eliminated 1 and -1. You can do that for yourself if you want to, just to double check my work. But 1 did not work in synthetic division, nor did -1. 5 did. Okay, so here's what I found when I got to my 5 and tested it. So my coefficients were 1, -15, 75, and -125. And you can see, in fact, that that 5 was a 0. It did work, leaving me this polynomial. Now, that's going to be able to factor quite easily for us to an x minus 5 and another x minus 5. Now, the 0 for this factor is another 5, and the 0 for this factor is also a 5. So with this one, we ended up with a single number. We had a 5. It was just repeated 3 times. So yes, there are 3 zeros for this, but it's a repeated 5 all 3 times. Okay. Now, here's something to point out to you guys. Once you find a 0 with this trial and error method, that doesn't mean it's the only time that a 5 could work in there as a 0. So here's a bit of advice or a thought to keep in mind when you're finding your rational zeros. If you find one that is in fact a 0 and you work it through synthetic division and it works nice like this one did, you might want to check that same number a second time so that you know whether or not it was a repeated 0. Okay, because you could, like on this one, we could have gone through that checklist if you hadn't been able to figure out how to factor it, and 25, -25, 125, and -125 would not have worked. So you might have thought that you did something wrong or came up with an incorrect answer. But this is repeated 3 times, this single 0. So there are 3 zeros, they're just all 5s. Checkpoint number 4 on 278. Let's find the rational zeros of this one. Okay, now I chose this one. It's a little bit bigger. Our constant term's not too bad, our -30, but it does have quite a lot of factors for options. Also, our lead coefficient is no longer a 1, it's a 2. So we have more options for that part of our check. So listing out our possible zeros. Plus or minus 1, plus or minus 2, 3, 5, 6, 10, 15, and 30, all over factors of 2, which are all of these. So any top paired with bottom are legitimate numbers to test. Okay, so they're not all zeros, but they are ones that are possible zeros. So again, I'm going to shorten this a little bit just for the sake of our notes in our video. 1 and -1 again did not work on this example. So I tried them. They didn't work. I eliminated them. When I got on to the 2, 2 worked. Okay, so let me just take you through that one. So working the synthetic process. You can see that it works. Now, when I take that 0 out, I'm left with 2x to the third minus 5x squared minus 28x plus 15. It's possible when you have this 4-term polynomial, as a result, when we divide out that first 0, you could possibly factor it with something like grouping. It doesn't work on this one, so I just have to continue testing more options. Okay, now, to rule out that 2 was a repeated 0, I did actually test the 2 again. Okay, it does not go in there again. I then went on and I checked 3. It did not work. I went on then and I checked -3, and it does. Okay, so let me show you what I did with the -3. So I was left with those 4 numbers after I got my 2 out. Okay. And here is my -3 working, leaving me with yet a smaller polynomial after I got that one out. Once I got here, and again, you could continue on with the same testing method, but I can factor at this point, so I'm going to bail out and finish with that. So my +5, I'm going to need 2 negatives to get that -11. So if I do a -5 here and a -1 here, I get my -11 in the middle. So my remaining 2 zeros I'm going to find from these factors. I get a 1/2 here and a 5 here. So my zeros on this one, first one I found was the 2. I then found the -3. Then I came up with a 1/2, and I came up with 5. Here are my 4 zeros for this polynomial. Now, we've talked about this a little bit in the first half of our chapter. If you know all of the zeros, you can find the function by taking the factors for those zeros and multiplying them back together. Okay, so that working backward, we have seen this before and done that. So in other words, if we had 5 and -5 as our known zeros, okay, the 5 comes from the factor x minus 5. The -5 came from the factor x plus 5. By foiling them back together and multiplying, this would have been the original function that had those 2 factors. Okay, so x squared minus 25 is the polynomial with 5 and -5 as zeros. All right, well, once in a while, we have some complex numbers in our zero set. Well, there is a rule in section 4 that tells us that if there is a complex number as a 0, its conjugate also has to be a 0. Okay, we talked about conjugates earlier again in the class. So -7i, I think you guys all recognize as a complex number. If -7i is a 0, +7i has to be as well. Okay, so obviously if you forget that fact, you're going to be down by 1 0 in your problem, and you'll be 1 factor short if you're going to multiply them back up to get that original polynomial. So you have to remember this rule. So once I see that complex number, I know I'm going to have another one, even if it wasn't listed there by the test question or by the textbook. Okay, so what are the factors for these zeros? This first one came from x minus 2. The second one came from x plus 2. The third one came from x plus 7i. And the last one came from an x minus a 7i. And now we have to do the math behind multiplying these together. All right, I'm going to FOIL the first 2 together because neither of them have an I in them. So if I FOIL together an x minus 2 and an x plus 2, I get x squared minus 4. I'm going to multiply the last two together now, and if I FOIL them, I'm going to get x squared plus 7xi minus 7xi minus 49i squared. Okay, so it's the same FOIL process. Notice what's going to happen with those two middle terms. I ended up with a positive 7xi and a negative 7xi. They're just going to go away. Hopefully you remember what I squared was equal to. I squared is equal to a negative 1. So I have a negative 49 times a negative 1 back there. I'm going to get an x squared plus 49. So thus far, multiplying the first two together, I got that. Multiplying the back two together, I'm now here. Now I can FOIL these last two parts and everything will be put together. So x squared times x squared. X squared times 49. Negative 4 times x squared. And negative 4 times 49, which is negative 196. The middle two are alike. They can combine. And here we are. All right, let's do another one. Okay, so again, I can see that I have a complex factor in there. I know that its conjugate must also be a 0. So I'm going to add it to my list. Now, to list out the factors that are part of this problem. Okay, well, the first two are easy. The 1 came from an x minus 1. The 3 came from an x minus 3. Okay, now is where you're going to really have to pay attention and figure out how these were working. I'm going to go ahead and put, because it's not a single digit, I'm going to go ahead and put those zeros in a parenthesis just to try to keep it organized on paper here. One of my zeros, or factors that came from one of these zeros, was an x minus my 4 minus I. The other one is an x minus the 4 plus I. Okay, now now that I have them written, I'm going to eliminate a couple of those parentheses before I start multiplying. So cleaning this one up a little bit, I have x minus 4 plus I. Okay, so I just got rid of my minus out in front of my parenthesis. I'm going to do the same thing over here. Okay, take a couple of seconds just to look that through. Now I'm going to change colors because I'm ready to start multiplying my factors together. I'm going to put the first two together first. Okay, it's a pretty simple FOIL. You're going to have x squared minus 3x minus x plus 3. Okay, so simplifying a little with my x things there. Okay, now I'm going to tackle those next two. Now they are trinomials. You have 3 pieces. Okay, so I'm going to put these two together. You have 3 pieces in each. Each term from the front factor needs to be multiplied by each piece from the back factor. That's going to be 9 things in all. Okay, so be very organized and very deliberate. I'm going to send my x through the other parenthesis first. So x times x. X times negative 4. X times negative I. Now I'm done with this one. I move on to the negative 4. So I've got a negative 4 times x. So I've got a negative 4x. I have a negative 4 times a negative 4 plus 16. I have a negative 4 times a negative I, which is a positive 4i. I'm done with this. I move on to using the I. I times x is a positive ix. I times negative 4, negative 4i. I times negative I is a negative I squared. Okay, now let's do some simplifying here. I'm going to do this just to keep that all separate from the front thing. There is only one x squared term. And I'm going to cross it off when I'm done with it. I have 2 negative 4x's. So this one and this one combine to make a negative 8x. And then I'm done with them. Now I have a negative ix here and a positive ix at the back. They're going to wipe each other out. I have a positive 4i here and a negative 4i here. They're going to wipe each other out. Negative I squared is a negative negative 1. This is a plus 1. So my 16 and that 1 can come together and make 17. These last two trinomials must be multiplied together. Again, if you have 3 pieces times 3 pieces, you're going to have 9 individual chunks. So I'm going to take my x squared and I'm going to send it through the second parenthesis first. X squared times x squared, x to the 4th. X squared times negative 8x, negative 8x to the 3rd. X squared times 17 is a positive 17x squared. I am done with this number. Moving on to my negative 4x. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 8x, positive 32x squared. Negative 4x times 17 is a negative 68x. I'm done with this one. Moving on to the last. I've got the 3 to use yet. 3 times x squared is positive 3x squared. 3 times negative 8x, negative 24x. 3 times 17 is a positive 51. Okay, finding like terms. There is only 1/4 power. This guy's gone. I have a 3rd power here and a 3rd power here. They can combine. So I'm going to have negative 12x to the 3rd. And then they are gone. I have I'm going to use a different color to underline. I have a squared one here, a squared one here, and a squared one here. So putting together 17, 32, and 3, let's see, 20 and 32 makes 52. So 52x squared, and now they're all gone. Then I have a plain x term and a plain x term. Negative 68 and negative 24 making negative 92x. And they're gone. And then there was just the one constant at the end. There we go. Okay, so that ends part 1 for us. We'll go on and finish the last half of this section together tomorrow. So for right now, focus your practice on page 285 for 1 through 50 for now. Okay, so that'll give you plenty of them to play with and find zeros and find polynomials back from zeros and so forth to get comfortable with what was in this section.